what I wanted to go over first was more on access modifiers. So we have class. That means that anything after that, until there's another label that overrides it, any code can access that. There are other labels, the other common one being private, which means that those fields or methods or constructors can only be accessed by other code that's part of this same class. For example, you may define like an integer in there, and then maybe you have like a get function which returns that integer, and maybe some other logic that can modify it, but someone wouldn't just be able to do a and then a dot x equals 7 or whatever. That would be an error because it would be hidden by the private access modifier. And again, because these are labels that apply until they're overridden, if you were to like have another field or method or whatever right here, it would also be private. One other label that exists is protected. So protected is similar to private, except that it can also be accessed by code in any subclass of A. So that would be used that's often used, for example, for constructors, and I'll get to how in a bit, but you could have a constructor that can only be invoked by a subclass. You could also just have certain utilities built in as member functions that you don't want to expose publicly because they're not meant to be and that could break something, but you want to expose to subclasses. There is one other place where you can use an access modifier, and that is when actually doing inheritance. So I'm not sure if anyone caught it last time, but when I was showing how you make a subclass of another class, you're going to make this a subclass of B. I wrote public B. That's supposed to be a curly brace. So you can. So this means that everything that's inherited by B will be at most public, which is sort of that just means it keeps whatever access modifier it had before. But for example, I could have written private there, which means that everything that we inherit from B will be treated as private, and so will the fact that A is even a subclass of B. And so anything outside of A will not be able to treat an instance of A as if it were an instance of B. It will not be able to access any fields or methods or anything that was inherited from B, and so forth. Does that kind of make sense? And it could also be protected. So whatever you put here sort of acts as a maximum level of access. What if I don't put a label here, or don't put a thing there? Because that's optional, but it should be more intuitive that this label is optional. I mean, you could just put stuff directly in a class. And the answer is that in a class, by default, everything is private. So anything that's before the first label that you put in, or everything if you don't put a label, is considered private. And if you don't put a label there, then this defaults to private inheritance. And you may be familiar with the concept of a struct from C. You can use structs in C++ as well. And what the language designers decided to do in order to maintain compatibility with the concept of a struct in C is in a struct in C++, by default everything is public. And in fact, that's the only real language level difference between a struct and a class in C++. You can use a struct anywhere where you can use a class, and they're basically treated as the same, except that when you declare it, or when you're defining it, the difference in inheritance, or not inheritance, the difference in by default how the default access level for members and for inheritance that's the only difference. There's often conventions around whether you would use a class versus a struct, The one that we kind of tend to follow is anywhere where you're just storing like the term that's often used is plain old data. There's no constructors, there's no methods, there's no fancy semantics around objects. It's literally just data. Then you would use a C style struct. Whereas if you're doing anything with methods or with constructors where you're more representing an object as opposed to a value and you're actually taking advantage of object-oriented programming, then you'd use a class. That's the convention that we like to follow. One final thing under access modifiers. Sometimes, for whatever reason, you need to declare or define a function that's not inside of a class, but you want it, but sort of you consider it to be like part of the package of the classes, and like it's maybe all the code's in the same place and written together, and so it should make sense that that function could access the private members of the class. And you can do that by putting in the class what's called a friend declaration. So for example, if earlier in the file because this would be in a header file, if earlier in the file we had a declaration for void foo, then inside anywhere, it doesn't matter, labels do not affect this, but labels, I mean access modifier, labels do not affect this. I can write friend void foo, and then the definition of foo can access any private and protected members of A, even though it's not part of A. And there's no other change in how you use foo or any other aspect of what foo can do. It's just it is given extra access level. You can actually do the same thing to an entire class. If you had another class called B, ignoring our inheritance structure here, find another class called C, you could do a friend class declaration. So I could say friend class C, which would mean that any code that's within the class C can access private and protected members of A, regardless of the fact that it's not part of A. The one key thing that can be that can trip you up here is that does not count as declaring foo. It will not work properly unless you have already declared foo, and then this is sort of a directive associating foo with A in some way, but that's not a replacement for declaring foo where you actually want it to be. So the foo needs to have already been declared in order for you to mark it as a friend of a class. And also this is a one-way relationship. If you want A to also be able to access members of C, you have to declare that there as well. Delegating constructors. This is a very useful concept when we're working with constructors for classes. So let's recap quickly the syntax for initializing fields from a constructor. So I'm going to have a class with two fields, an int and a string, and I'm going to make a public constructor. Note that these two fields both will be private, like we just discussed, because they're before any label and this is the class. So let's create a constructor. Let's make it the default constructor. Let's say x defaults to -1 and s. Let's just omit s this time. Okay. So what we've done here is we've said, okay, when the default constructor, being the constructor with no parameters, is invoked, we initialize x to -1. We could also have another constructor which initializes x to a value x that's passed in. this looks weird, right? X with X inside. The reason why that's valid is, this is a brief discussion about variable scope. So here, the only thing that can go here is the name of a field. So it's not ambiguous that I'm talking about that X. And here, this is an expression in the context of the constructor. So first it looks for an X in the scope of the constructor itself, finds one in the parameter list, and that's the X that's talking about here. So that's a fairly common pattern you'll see with the exact same name for a parameter and a field if it's literally just a parameter that's being used to initialize a field. And they're logically supposed to represent the same thing. But that's how you actually write in code, and that's why it works. Does that make sense? Now, in both these cases, what is S initialized to? It is not null because it's not a pointer. It cannot be null. It is the string type that's built into the C++ standard library, so it always represents a real string.
So just empty?
Yeah, it's an empty string because its default constructor gets invoked implicitly because every object in C, so everything that's not a primitive type like a pointer or an int or a float, everything that's a class type, which includes string, needs to be initialized. If you don't tell it how to initialize it, it tries to invoke the default constructor, and you'll get a compile time error if that class does not have a default constructor. This will implicitly invoke the default constructor to initialize S, and the default constructor for the built-in string type initializes it to an empty string. Now, let's say that maybe we here's one thing we can do with this. Right, so let's say we want a third constructor that maybe, what if we did this? If this constructor was invoked, so this is a const reference to a string, and we're initializing S based on that. So basically means we're passing a string in and initializing S to be that, exactly the same as here we're passing an int in and initializing X to be that. That make sense? After this constructor, what's X?
It's the same. You haven't changed it
But you didn't pass in one either.
I haven't changed it from what?
from what was on the previous line. Like
No, these are different constructors that we're
different
declaring.
different construct. Okay.
Whatever the default integer value is.
Which is 0. And note that there's only a default value in the context of global variables and fields and classes. If you just have a local variable in a function and you put an int, and if you put int x and you don't initialize it, whatever happened to be in that 4 bytes of RAM or register in the CPU, however the compiler decided to figure it out, whatever was there before is what will be there. Yeah. But in this case, because this is talking about the field of a class, it does get initialized to 0. Now, in this case, we could say this may not be obvious immediately why this would be useful, but what we could have done instead, let's say if we wanted, I don't know, maybe in some hypothetical scenario, this default constructor included a lot more functionality than we're showing here. We could do this. Instead. So if instead of this being empty, if there was a whole bunch of functionality here that we didn't want to copy paste, one possible thing we could do is this. This is what's called the delegating constructor. So this constructor is basically saying, actually, I'm just a little bit of added functionality on top of that constructor. So what it does is it first invokes that constructor with the parameters you provide, which in this case is none because it's a default constructor, and then it does the body of the constructor, which in this case copies the string that was passed in into the field. And in this case, because we're in the body of the constructor, we need to specify. We need to, because by default, so if we just say S, it looks in this scope and finds an S in this scope. But in this case, we don't want to talk about that S. If we want to talk about that S, we have to qualify it by saying the S that's on this object. And the other thing here is because every field can only be initialized once, right? Because initializing it is calling a constructor, and you can't construct an object that's already being constructed. You can't add additional member initializers like we had before here. So we couldn't have just put S bracket right here. Instead, we would need to assign it in the function body here. That's a restriction again because we can't call a second constructor here. That's actually assignment instead of a constructor. There's one other place where that's very useful, and that's when we're talking about inheritance. So let's say, let's just say we have just that. Okay. And then later we have a subclass of A called B. Now, let's say it has its own int y, which maybe serves a different purpose than the int x. Now, remember that when B inherits from A, what that means is that every instance of B is also an instance of A, and it's effectively like there's an object of type A that's embedded inside the object of type B, like as if it was a field, right? So that object of type A also needs to be constructed. So by default, if we just had a rather simple constructor like that, you agree that that if we then this goes off, if we then did that B object would have a field called y of type int, right? It would also have a field of x, field called x of type int, and a field called s of type string, right? What would x and s inside B be initialized to?
-1 and empty.
Correct, because by default that implicitly invokes the default constructor. But let's say we want by default, and of course, in order for these classes to be useful, there would need to be more member functions and whatnot that could do different, like manipulate and access these fields in different ways. So let's say it was more useful if by default x and y were the same value. Then what we do instead of just letting it invoke the default constructor, we would do that. So what that says is, okay, initialize the embedded object of type A by calling its constructor, or whatever constructor matches passing in y, which would match with this constructor, and so it would initialize x to also be the same as what we're initializing y to. Now, could I have just done this instead? The fields in the embedded A object have already been initialized at this point because we didn't tell it how to initialize A, so it just called the default constructor. So these have already been initialized, so I can't initialize them again for the same reason that that our delegating constructor here couldn't reinitialize S. And on top of that, X is private, which means that B cannot access it. So in order to get that behavior, this is the syntax you would use.